Dear students, welcome to experiencetutor.com. Today we are going to start with Physics Numericals Motion in One Dimension Part 3. Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you. Question number 1. A person walks at a constant speed of 5 meters per second along a straight line from a point A to point B and then back along the line from B to A at a constant speed of 3 meters per second. What is her average speed over the entire trip? Her average velocity over the entire trip. A. Here we need to find out the average speed. So total distance upon total time taken. Total distance say is d plus d upon total time taken is d upon 5 plus d upon 3. So 2d upon 8 d upon 15. So after solving it we get approximately 3.75 meter per second. Say starts and finish at the same point A, therefore total displacement is 0. Average velocity is equal to 0. Question 2. The position of a particle moving along the x-axis varies in time according to the expression x is equal to 3t square, where x is in meter and t is in second. Evaluate its position at t is equal to 3 second and at 3 second plus delta t. C. Evaluate the limit of delta x upon delta t as delta t approaches to 0 to find out the velocity at t is equal to 3 seconds. A. At any time t, the position of a given the position is given by x is equal to 3 meter per second square t square. Thus t is equal to 3, x is equal to 3 into 3 square, which is 27 meter. B. At t, f is equal to 3 plus delta t. So tf is equal to 3 plus delta t whole square, which is equal to 27 plus 18 delta t plus 3 delta t square. This is the final position.
See, the instantaneous velocity is at t is equal to 3 second is v is equal to limit delta t tends to 0 x f minus xi upon delta t. Limit delta t tends to 0, 18 plus 3 delta t, that is 18 meter per second. Question 3. Starting from the front door of your ranch house, you walk 60 meters due to east to your windmill, and then you turn around and slowly walk 40 meters west to the bench where you sit and watch the sunrise. It takes you 28 seconds to walk from your house to windmill and then 36 seconds to walk from the windmill to the bench. For an entire trip from your home to bench, what are A. your average velocity and B. your average speed? As we know that average velocity is equal to displacement upon time, therefore let plus x be east. Therefore delta x is equal to 60 meter minus 40 meter, that is 20 meter, and delta t is equal to 28 seconds plus 36 seconds is equal to 64 seconds. So average velocity will be delta x upon delta t, that is 20 upon 64, that is 0.312 meter per second. B. Average speed. Average speed will be equal to 40 meter total distance upon total time, that is for 60 plus 40 60 meter plus 40 meter upon 64 second, that is 1.56 meter per second. The average speed is much greater than the average velocity because the total distance walked is much greater than the magnitude of the displacement vector. A Honda Civic travels in a straight line along a road. A Honda Civic travels in a straight line along a road. Its distance x from a stop sign is given as a function of time t by equating xt is equal to alpha t square plus beta t square plus beta t cube, where alpha is equal to 1.5 meter per second square, beta is equal to 0.0500 meter per second square. Calculate the average velocity of the car for each time interval. A. T is equal to 0 to t is equal to 2 seconds. B. T is equal to 0 to t is equal to 4 seconds. C. T is equal to 2 seconds to t is equal to 4 seconds. The average velocity is equal, v is equal to delta x upon delta t. Therefore, we'll use t to find x for each t. So x0 is equal to 0, x2 is equal to 5.6 meter, x4 is equal to 20.8 meter. Average velocity will be 5.6 minus 0 upon 2, that is plus 2.8 meter per second. And second case, average velocity will be 20.8 meter minus 0, that is upon 4, that is 5.2 meter per second. C will be average velocity will be 20.8 minus 5.6 upon 2, that is 7.6 meter per second. The average velocity depends on the time interval being considered. Uphill at 40 km per hour and then back downhill at 60 km per hour. What is the average speed for the round trip? In this case, we'll take average speed as total distance covered upon total time taken. So d up plus d down is the total distance covered, and t up plus t down is the total time taken. Therefore 2d upon d upon v up plus d upon v down. So if we cancel d, we'll get v up as 40 km per hour and put v up as 40 km per hour and v down as 60 km per hour. Then we'll get 48 km per hour as an average speed. Question 6. Position of an object moving along an x-axis is given by x is equal to 3t minus 4t square plus tq, where x is in meter and t is in second. Find the position of the object at the following values of t. A is equal to 1 second, B is equal to 2 second, C is equal to 3 second, D is equal to 4 second, E is equal to what is object displacement between t is equal to 0 and t is equal to 4 second, F what is the average velocity between t is equal to 2 second to t is equal to 4 second, G draw a graph x versus t for t is greater than equal to 0 and smaller than equal to 4, and indicate how the answer of f can be found on the graph. So using the equation x is equal to 3t minus 4t square plus tq, we'll get x is equal to 3 meter per second into t plus 4 as minus 4 meter per second square t square plus 1 meter per second q tq. Now we can plug t is equal to 1 in the equation, which will give 0. T is equal to 2 in the same equation, it will give x is equal to 2 meter, and t is equal to 3 in the equation will get x is equal to 0 meter. Putting 4 t is equal to 4 seconds in the given equation, it will give x is equal to 12 meter. If we subtract the position at t is equal to 0 and position at t is equal to 4, we get the displacement, that is delta x is equal to 12 meter. The position at t is equal to 2 second is subtracted from the position of t is equal to 4 second will give the displacement delta x is equal to 14 meter. Now average velocity is delta x upon delta t, that is 14 meter upon 2 second, that is 7 meter per second. We can find the same from the graph. The position of the object for the interval t greater than 0, greater than or equal to 0 and less than or equal to 4 is plotted below. The straight line drawn from the plot at tx is equal to 2 seconds comma minus 2 meter to 4 seconds comma 12 meter would represent the average velocity of the part F. The relation 3t is equal to root 3x plus 6 describes the displacement of a particle in one direction where x is in meter and t is in second. Find the displacement when the velocity is 0. To solve this, we'll write the equation under root 3x is equal to 3t minus 6. Squaring both sides will get x is equal to 3t square minus 12t plus 12. Again, if we differentiate both the sides, we'll get dx by dt 6t minus 12. Put v is equal to 0 gives t is equal to 2 seconds. Using equation 3 in 2 gives the value of displacement x is equal to 0. Question 8. A man of height 1.8 meter walks away from a lamp at a height of 6 meter. If the man's speed is 7 meter per second, find the speed in meter per second at which the tip of the shadow moves. Let the lamp be at height h from the ground, that is AB is equal to h. Let the man be initially at B, below the lamp, his height being equal to BD is equal to h. So the tip of the shadow is at B. Let the man walk from B to F in time t with speed v. The shadow will go up to C in the same time t with velocity v dash. Bf is equal to Vt, Bc is equal to v dash t. From similar triangle EFC and ABC, FC by BC is equal to EF by AB is equal to H small h by capital H. FC by BC is equal to EF by AB is equal to small h by capital H, which tends to V dash t minus Vt upon V dash t is equal to h by small h by capital H. Therefore, V dash is equal to capital H V upon capital H minus small h. Now putting the values of capital H and V, we get 10 meter per second.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.